For number 7, we have 3 to the x is equal to 81. Okay. Well, 81 is the same as 3 to the 4th power. So since we're equating like bases, you can just set the exponents equal to each other. So this means x must be 4. Okay, for number 9, 6 to the power of x minus 2 is equal to 36, which means 6 to the power of x minus 2 is equal to 36 is 6 squared. Okay, now the bases are the same, so now I can just equate the exponents. And adding 2 to both sides gets me x equal to 4 again. Number 11, 1/2 to the power of x is equal to 32. Okay, now I could rewrite 1/2 using a negative exponent, because 2 by default is a power of 1. So I can write this as 2 to the negative 1, still being raised to the power of x. Okay, a power raised to a power, you multiply them, so this would be the same as 2 to the negative x. Okay, now I need like bases, so 32 is the same as 2 to the 5th power. So now that I have like bases, I can equate the exponents. And I don't want to know what negative x is, I want to know what x is. So mentally multiplying both sides by a negative 1, that means x is negative 5. Okay, so 11 is done. Number 13, 1/3 to the power of x minus 1 is equal to 27. Okay, so the 1/3, again, I'm going to use a negative exponent, write 3 to the negative 1 to the power of x minus 1. And on the right side, I'm going to go ahead and convert the 27 using a like base. 27 is 3 cubed. Okay, on the left, a power to a power, you multiply them. So distributing the negative 1 to the x minus 1, I would get negative x plus 1 is equal to 3 cubed. So now the bases are the same, so I can equate the exponents. Subtract the 1 to the other side. Multiply both sides by a negative 1. So x is negative 2. Alright, 13's done. Number 15. 4 cubed is equal to x plus 2 quantity cubed. Let's see. Okay, so since the exponents are the same, I can equate the bases. So 4 is just equal to x plus 2, and if you subtract the 2 from both sides, you get 2 is equal to x, which I just prefer to write as x equals 2. So x is 2. Number 17, and I tell you what, let me copy these last 3 down again. I'll bring these down. So number 17, x to the 3/4 is equal to 8. Alright, now this one's I'm going to do this a little differently here. I want to know what x is. And I want to know what x is, which is the same as saying x to the 1st power. Okay, so to do this, I'm going to raise both sides to the reciprocal power, so 4/3. Okay, because 3/4 times the 4/3 gets you 12 over 12, or 1. Okay, that's why I'm multiplying by the reciprocal of what they gave me. Alright, so now I have x is equal to 8 raised to the power of 4/3. And going back to how we did earlier problems, that means the denominator is my index, and the numerator is my power. The cube root of 8 is 2, which I'm still going to raise to the 4th power, and 2 to the 4th power is 16. Okay, so number 17 is 16. Alright, and usually you will want to be able to do these by hand, because even if your teacher allows a calculator throughout the course, a lot of times they will have a calculator and non-calculator part for this kind of information. Not always, but sometimes, so make sure you check. E to the x equals 5. Okay, so I'm looking for x. Now this one we need logarithms to get to x. Okay, so as a side note, if you're given an exponential, let's write it as y equals b to the x. Okay, converting that to logs. That's the same as writing log base b of y is equal to the exponent x. Okay. So what I did is I took, let me do this in red real quick. I took this base and I went to that side and then I went to that side. Okay, as far as converting it into this thing. Okay, a little confusing at first, but once you do it a few times, it's not that bad. So what I'm going to do is I'm going to rewrite this as log base e of 5 going to the other side of the equal sign equals the exponent, so x. So, and I'm just writing my x on the left side. Okay, and then, so we want to note this thing first, and then secondly, to say log base e, there's another notation for that. It's called natural log, so ln. So instead of writing it as log base e, you should write it as natural log, or ln, of 5. And whatever that is, you can type that into the calculator, but if your teacher asks for an exact answer, you would just leave it like that. If you convert it to a decimal and round it, you're approximating the value, so it's no longer exact. Last one is 21, and again, let me copy this real quick. Okay, so since the bases are already the same, I can just equate the exponents. Divide both sides by a -2, so x is equal to 5 over -2, or x is equal to -2.5. Alright, and that completes that part of section 1.6, that portion of it.